Hey Tatiana, so for these exercises you are going to have to master several properties of square roots or roots in general, because you have square roots, for example, in this exercise on 27 and 33, but you have cubic roots on the 36. So I mean the root properties are for all types of roots. All right, so let's do a little review of them. So whenever you have, let's say that you have two factors inside a root, then you can separate this on different roots. This only works for multiplication if you have product, and you can also do the same thing for a division. So for example, if you have a over b and we have the root of all of this, then you can just place the root in the numerator and the denominator, right? So for example, if you have, I don't know, 9 times 3, for example, then you can just separate this as square root of 9 and the square root of 3, right? So this is these are a couple of the properties. Now, also, it's going to be important to be that you have to remember is that, for example, if you have a base and the exponent has the same index of the root, so for example, we have a square root with a squared power, then you can just cancel the root and the power because they are inverse operations, and it's going to leave you only with the number inside. And this applies to any kind of root. So for example, let's say that you have, I don't know, 2 to the 8, and by some weird exercise, you have the 8th square of something, right? Then you can just cancel this 8 of the root with the 8 of the power because they are opposite operations, and then you're going to end up just with the factor in the inside of the root. All right, so that one is quite important because we're going to use that a lot for these exercises. All right, so another important property is how do you convert the square root, well, any root, into an exponent. All right, so this one is going to be really helpful if you have some harder roots down the road. So for example, I'm going to use a little bit of algebra now. So if you have a base and it's, let's say that this is x to the m, and you are going to have the nth root, right? So that could be any kind of root. Then you can convert this into an exponent this way. So the exponent m is going to stay the same, and the n of the root is going to go into the denominator. So let's do a quick example about this. So let's say that, for example, you have, I don't know, 3 to the 4th, and let's say that we are using again an 80th or whatever you call that root. So you only have to do this. So we place the 4 in the numerator and the 8 on the denominator. And then you just have to simplify the fraction. And that is, I think this is way easier, especially for difficult roots like this one. This is way easier to simplify than to think, well, what is going to be the 8th root of 3 to the 4, right? It's easier to see it this way because then you can just simplify. So 4 over 8 is the same that, let's divide by 4. So this is the same as 1.5. And then you can convert it back into a root. So you could put this like, for example, the 1. Just have to be mindful of this property, all right? So the numerator is the exponent of your base, and the denominator is the index of the root. So this way is simplified, all right? So both of these expressions are the same. Now it's going to be kind of weird that you find this sort of roots, but it's helpful. Okay, so now onto your exercises so we can see a little bit more things. So for example, in the case of 27, where you have the square root of 180, that's going to be kind of hard to know just by looking at it how you can simplify it. So what you can use, you can always use these kind of things, is a prime factorization. So you just have to grab the number. So for example, in this case is 180. And let's start deconstructing these numbers. So half of 180 is 90, and half is going to be 45. Now, we can't divide by 45 anymore, so we're going to do it by 5. So 45 divided by 5, sorry. Oh yeah, this here's a 5, and it's going to be 9. And then the 9, we can simplify this as 3. And then as 3 again, right? So this is just a prime factorization. Maybe you know how to do it in a different manner. The way that I'm familiar with is this kind of table way, but if you know any other, it's the same. The important thing of this factorization is that, for example, in this case, you have a square root, right? So there is an index 2 over here. So we're going to want to group all of these numbers in 2s, right? So we're going to group them in pairs. So these 2 are going to be interesting for us. So 2 times 2 is just 2 to the 2. And both of these number 3s, these are also 3 to the second power. Now, why do we want that? Well, because what we know thanks to this factorization is that the square root of 180 can also be expressed as 2 to the 2, or 2 squared, times the number 5 times 3 squared. So if you all do all of this calculation, then you're going to come back to the number 180. Now, why did we want to pair these numbers? Well, because you have to remember this property, where whenever we have a product inside of a root, it doesn't matter which kind of root it is, then we can just separate this into several roots. So we can do this. We can just write 2 to the 2, and in a different root, we can just write the number 5. And in a different root, we can just write 3 to the 2. Now, I should have reordered this. Well, you're going to see why I should have reordered this in a well. I mean, it's not wrong. It's just going to be a little bit, I don't know, weird. So you can cancel out this square root with this power, and this square root with this power. So what you are going to end up having is going to be 2 times, right? So I'm going to write it in parentheses now. So 2 times the square root of 5. We're not doing anything with this root because it's not an exact root, so we're going to leave it just indicated, right? So we have the square root of 5, and then we have the 3, and then we just multiply 2 times 3 is 6. So this is going to be 6 times. All right, we can forget the parentheses now. So this is going to be 6 times the square root of 5, right? So that is why this is important. Now, it's not necessary to do all of this if you're pretty good with your multiplications and stuff like that. So, for example, let's do the number 33, or I mean, at least let's do a little bit of it. So, on the number 33, there is another way that you could approach these exercises, and the way that you approach these exercises, it's highly dependent on the student. right? So there are some people that feel very comfortable just doing these factorizations, and there are other people that like to think the way that I'm going to teach you now with this exercise. So you can use whatever you see the easiest, all right? So always use the easiest path, So for example, 72, what I can realize over here is that I can actually write the 72 as 9 times 8. Now, why do I want to write it as 9 times 8? Because the 9 has an exact square root, all right? And you're going to see why this is going to be helpful. Now, the number 8, I could also write it as, let's see, 4 times 2. So I'm going to respect this 9 over here. And instead of writing 8, I'm going to write 4 times 2, right? Because 4 times 2 is 8. And you're going to see why am I doing this this way in a while. And oh, I forgot the square root of 63. So with this one, we are going to do the same. And in this case, all right, so 63, you can express it as 9 times 7. Now, why did I use this sort of I'm sorry, I I lost my train of thought. Why did I use these products? Well, because the 9 has an exact square root and the 4 has an exact square root. So whenever I get all of this, remember that you can separate these square roots because on the inside, there's a multiplication, there's a product. So we can just write it like this: square root of 9, square root of 7. And we can also do this with the other, with this part. Now, what I would normally be doing is that as soon as I can see this, I would simplify it, but I'm just writing it all down for you so you can see how is it that there are some things that we're leaving the same as they are, and there are another things that we are going to rearrange them, right? So we have over here the square root of 9, and let's separate all of them into different roots. Now, again, you don't have to do all of this procedure. Right now, I'm just writing it so you can see it because you are starting to learn these kind of properties. But once that you are acquainted with them, then you can just start skipping steps, all right? So the square root of 9 is going to be 3, and then 2, and reconnecting. Wait, what's going on? And okay, it's back. So the square root of 4 is going to be 2, but the square root of 2 is not an exact root, so we're going to leave it that way. So it's going to be a square root of 2. And the square root of 9 is going to be 3. And the square root of 7 is going to be, well, the same because it's not an exact square root. So now we just have to multiply these numbers. 3 times 2 times 3 is going to be 3 times 2 is 6, times 3, 18. And we can write, so remember that whenever you have two separate roots, you can actually mix them into one. So the number 2 and the number 7, we can just place it inside of the roots. And then in the end, you just have to do that product. So 2 times 7 is going to be 14. So we could simplify this this way, right? Now, there are several things that you can do. You can think about them in terms of multiplications or maybe do the factorization. So for example, if you did this same table of the number 72, all right, you would have arrived at exactly the same number. So for example, we can cut this in half. This would be 36 half, 18 half, 19 third, 3 third, 1. Right. So again, the ones that we care about are the ones that we can pair up. And in this case, it's because we have a square root. So if there's a 2 over here, then we are interested in the powers of 2. Now, when I show you, I'll just really quickly the number 36. I think this is taking too long, but There are a lot of properties, and you had a lot, a lot of examples. So, for example, on the number 36, because we have a cubic root, then we would actually want to find numbers that are repeated in threes, right? So, for example, 1 to 3, those would be interesting for us in the case of a cubic root, all right? So, coming back to this idea, so check it out. This 2 to the power of 2, all right, this 2 squared is 4, so it's this 4 over here. And this 3 squared is the same as this 9, and this 2 that is left alone is this 2. All right. So you would be able to find the absolute same values, and it doesn't matter which way you choose to go. Just choose the one that it's easier for you. So what would happen with the cubic roots? Now, we're not going to do the whole exercise, the 36 exercise. I just want to show you what would happen, for example, with the number 16. So if you would make this factorization, right? So you can do the same. So let's have it. So it's half 8, half 4, half 2, 1. And you can always check that you are doing a correct factorization if you multiply all of these numbers. So 2 times 2 is 4, times 2 is 8, times 2 it's 16. So it's done correctly. Now, since we are talking about a cubic square root, I don't care right now about the other one. You can do the other one calmly. So because there are an index 3 over here, I want the numbers that are repeated in threes, all right? So I'm going to pick 1, 2, 3 number 2s. So this is going to be 2 to the 3. And I want to choose that because remember, we want numbers that we can simplify with the root, all right? So this is going to be 2 to the third, to the 3, and this 2 is going to be left alone over here. And then remember, we can separate these roots. So this is going to be the cubic root of 2 to the 3 times the cubic root of 2. And then you can just cancel out the cubic root with the third power, and then you're going to get only the number 2. And that's it, right? Now, of course, you would have to do all of this simultaneously with the other root, but this is just an example so you can see the importance of this factorization, right? So it's easier. I think it's easier to work this way, but I mean, there are several ways that you can use to arrive to the same answers. All right. So, well, I hope this helps, and good luck with your exercises.